When voltage are less than 56 volts, it is showing charging sign that battery is less than its required level. We can adjust the sensing voltage from this potentiometer. When battery will reach at 56 volts, it will disable this signal and it will enable this signal that battery is fully charged. We can connect this output to any next circuit, any MOSFET, any relay to control the charging process. In my last video, I shared how to design 12 volt battery monitoring circuit. It sends the battery voltage, standalone reference, it compares the battery voltage and provides charging or fully charged indication on these LEDs. I received a comment how to monitor 48 volt battery circuit. If you are using with any MOSFET or relay, that will be used as a battery cut circuit or battery auto cut circuit. Let's modify this circuit to make it for 48 volt battery. In my last video I explained the complete process, but I will explain with more details so that you can make any voltage comparator using this IC. Let's start. Assalamu alaikum wa rahmatullahi wa barakatuh. I am your host Muhammad Ashraf and I welcome you on my YouTube channel. If you are new to my channel, I will invite you to subscribe it. And you can press bell notification for all so that you will be notified for my every new video. We are using LM324 IC. It is 4-channel operational amplifier. We will use same 12 volt Zener diode. If you are monitoring 12 volt, then we can use 7-8 series voltage regulator. But when we are monitoring 24 volt battery, that voltage may reach up to 30 volt. So that is unsafe for linear regulator. For that purpose, we can use any buck regulator that will save. Now we will use same BZX85C12. It is 12 volt regulator, 1.3 watt. It can handle normally, but we will not use at full range. We will use it approximately 30 to 40 milliampere based on requirement of this circuit. So we will use at 40 milliampere as we used in last video here. When we are monitoring 48 volt battery, the nominal battery cutoff voltage will approximately 54 to 56 volts. We will consider 56 volts. We need this resistor value. It is series resistor. V supply minus V Zener divided by I Zener. Supply voltage 56 volt minus 12 volt Zener voltage, that are nominal voltage. Its voltage may vary from 11 to 13 volts. I Zener current, that is 0.04 ampere. Let's calculate resistor value. 56 minus 12 divided by 0.04, 1100 ohm. Power rating multiply with 0.04 square, 1.76 watt. If we will design for 30 milliampere, 56 minus 12 divided by 0.03, that is 1466 ohms, multiply 0.03 ampere, that will 1.3 watt. We can use 1500 ohms or 1.5k. That time we will receive 30 milliampere. If we will use 1.1k at 2 watt rating, that time we will receive 40 milliampere. So let's say 1100 ohm and 2 watt. These are 12 volt for IC. Same circuit. Pin number 4 will receive regulated 12 volt. Our battery voltage, charger voltage are here. But this IC will receive 12 volt because its maximum limit is 32 volt, 30 volt. We will use only two sections. Pin number 11 grounded. Same power supply return that will be connected here. Pin 2 inverting input. Pin 3 non-inverting input. Pin 1 output. Power supply lines are common for all four sections. Second channel, pin number 6, inverting, pin 5, non-inverting. Same voltage will be used to create reference voltage. We will use 4.3 volt Zener regulator. Same way, we will calculate this resistor value. From this voltage we will operate this IC, but from this section we will provide only reference signal. From this channel we don't need any high current, so 10 milliampere, 15 milliampere is excellent. Let's suppose 15 milliampere as we calculated in this section in last video. 56 minus 4.3 divided by 0.015. It is 3446 ohm. For this resistor, we will calculate V supply minus V Zener divided by I Zener. 56 minus 4.3 divided by 0.015 ampere. It is 3446 ohm. To calculate power rating, P is equal to I square R. I current and resistor value 3446 ohm multiply with 0.015 square, 0.775 watt. So we will use 1 watt. Here we will use 2 watt or 3 watt, but here 1 watt is enough. It is 3446, so we will use standard resistor 3.3 kilo ohm, 1 watt. We will feed this signal to pin 2, that is inverting input. Battery voltage signal we will connect to pin number 3. Now we need voltage divider network, same as we created here. This line was 18 volt, but now we are sensing 56 volts. One resistor, we will create a variable signal to compensate tolerance of these components, so we can adjust as per our requirement. Combination of these two resistors will be considered as low side resistor from this voltage divider network. This is high side resistor and this is low side resistor. We have 56 volt divided by 0.001, 1 milliampere is good. So total resistance in this channel will 56k. RT 56 kilo ohm. Here we are creating 4.3 volt reference. So we need 4.3 volt in this channel when battery voltage are full. 4.3 volt. 4.3 divided by 0.001 current 1 milliampere. We need 4.3k resistor. Potentiometer plus this resistor 4.3 kilo ohm. So we will use 3.3K standard resistor plus 2K potentiometer in series. It will give us window from 3.3 to 5.3K. Total 56K minus 4.3K, 51.7K. Now we can use 51K. Now we have facility here to adjust the resistor value. Now this signal will reach to pin number 3. We applied these reference voltage to inverting input. Now when voltage are increasing, when it will exceed from this level, it will provide high output. And this signal will be provided to pin number 6 here, that is inverting input. Here non-inverting and here inverting input. This signal so both channels will work opposite to each other. I will use 1 kilo ohm resistor, that is just for demonstration. If you are using for long-term operation, that time 2.2K, 3.3K, 4.7K, 10K resistor, that is much safe. LED will turn on, it will give slightly dim light. At 1K, the LED will full bright, but it will create load on this Zener diode. If you are using for long-term operation, that time 4.7K, 6.8K, that's nice. Zener diode will remain safe. I am using 1 kilo ohm resistor. Moreover, if you want to trigger any next circuit, using this Zener regulator we cannot drive relay. Positive voltage, source, drain, gate. We will connect 10 kilo ohm resistor between source and gate. Here are plus 60 volts. P channel MOSFET with low RDS on. If you will connect this signal here, when voltage are less than required threshold, it will turn on this transistor and it will turn on this MOSFET, because MOSFET gate will at low side, P channel MOSFET, so it will allow voltage to the next circuit. When this transistor will disconnected, MOSFET will cut off, next voltage will be blocked. I have 1.5K resistor. I will connect to positive side, and here I have BZX85C12. It is 12 volt Zener regulator. We calculated 1.1K, I am using 1.5K, so it will decrease the amount of current, but no problem, because this time I am just demonstrating. If we are calculating and we are using the same components, same calculated current will in output. I don't have 3.3K, 3.4K, I am using 10K resistors, 3 in parallel, so total resistance will 3.3K. Positive line, Zener diode, cathode, and this end is ground. One resistor, second resistor, and this is our third resistor. 3 resistors in parallel to create 3.3K. But when we are making project, that time we need exactly same value resistor, 3.4K, 3.3K. Yes, it is 3321 ohm. We calculated 3446, so it is closer value. Cathode is connected to the resistors, anode is grounded. From here we will receive positive 12 volt, here 4.3 volt. Now we want to create this signal. 51k resistor to the positive line, and we will use 2k variable resistor trim pot to create a variable voltage signal. So it is battery signal. That signal we are comparing with our reference signal, that is 4.3 volt reference signal. And we will use 3.3k with one end of the potentiometer. It is 50k and this is 4.5k. Positive voltage at pin number 4. 1, 2, 3, 4. Common to pin number 11. 8, 9, 10, 11. This is common line. To protect this IC from intermittent switching due to input offset, we will use 1 mega ohm resistor between non-inverting input and output for each channel. Here non-inverting input is pin number 3, 1 mega ohm. Same here, pin number 5, 1 mega ohm. I will use 1k resistor at output side. LED anode, cathode will be connected to ground. Same way here, 1k resistor, LED anode with resistor and cathode is grounded. Pin 1 resistor, LED cathode connected to common side. Same way here, pin number 7, 1k resistor second end, LED anode, cathode grounded. We need 1 mega ohm resistor between pin number 1 and 3. So it is positive feedback resistor. This time I don't have P channel MOSFET. I will arrange that MOSFET and I will connect to this circuit. So this positive feedback resistor is connected here. Now we need to connect this reference signal to pin number 2. This 4.3 volt reference signal to pin number 2 and pin number 5. Here is pin number 2. We will make jumper from pin number 2 to pin number 5. 4, and this is pin number 5. Battery sense signal, that is battery level monitoring signal, provided to pin number 3. Same, pin number 3 will be connected to pin number 6. I don't have 60 volt battery or 60 volt power supply. I will use 2 voltage booster modules to create our required voltage value. I will use in series. This is one module and this is the second one. It is to simulate the battery voltage. I will provide 12 volt from a 12 volt power adapter to this module, and I will provide another 12 volt power supply to second module. We cannot power up both modules with same power source, so we will need two 12 volt sources to turn on these modules. This is common. We have 42 volt at our DC rail. First we will adjust the voltage to our 56 volt power supply, that are battery voltage. So I will adjust both power modules, booster modules, to obtain our required value. First we will adjust to our required value. We need to switch the voltage at 56 volts, 54, any voltage value. Let's suppose 55.6 volt. Now I will adjust this potentiometer to calibrate this circuit. Yes. It is showing charging sign. This LED is now turned on. When voltage are 56, fully charged sign is here. Voltage will drop 55.5 volt. Charging sign is on. Let me change the LED with red color, so that will give a clear view. Perfect. When battery voltage are up to 55.4 volt, it is showing charging. That battery is not fully charged. It is less than the allowed limit. Voltage reached at 56. It changed its output to fully charged indicator. Reference regulator is providing 4.4. We calculated 4.3. Its output may be 4.2 volt to 4.4 volt. What is your feedback about this video? If it is good, give a thumb up. If you have any observation, if you have any question, any note, any recommendation, please write in the comments. And if you have not subscribed my channel until now, I will invite you to subscribe my channel. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.